is Engineer Ali Mustafa. I am here with Professor Ali Shahab from the American University of Beirut. We are presenting our pipeline, which is called Vcdissect, which is an efficient pipeline for vertebral column patching in medical images. First of all, we're going to show the outline of our presentation. We'll first go into some introduction, the objective, and we'll show the different phases of our pipeline. We first work on the isolation phase, and then we work on the patching phase, and then we're going to show you some conclusion and future work. First of all, as an introduction to this work, of course, it's very well known that working with DICOM format and other complex imaging format introduces some challenges. And in our case, to generate some region of interest and patching from these images is very complex and very challenging. So we are trying to create here the pipeline to be used later in AI models. Of course, because this is a very crucial area in AI model and AI training is to find the region of interest of the area we are trying to work at. In our case, we look at the vertebral column into the DICOM images, of course, the sagittal view of the 2D DICOM images. As we see, there are previous researches, but they are not that accurate. They show the vertebra in areas, they don't show patching. And even in another research, as they try to find the vertebra and segment the specific vertebra or patch it, there's a little misalignment and inaccuracies, which also cause inaccuracies in the final output, especially if it's an AI model, not a real radiologist. So our objective in this case would be to develop a pipeline to efficiently derive regions of interest from 2D sagittal view from medical images, in this case DICOM, and we are focusing on vertebral column. Of course, this is a tool that will be used later in other projects to be to extract the vertebral patches or the vertebra, the specific small vertebrae. First of all, we need to talk about the isolation phase of Vcdissect, our pipeline. As an overview of the isolation phase, the first step is isolating the whole vertebral column from the DICOM image. So we need to take out only the vertebral column from the DICOM image. And to accomplish this task, which is a very complex task, we leverage what's so-called a UNet model. So there's the first presence of AI in our project. The UNet model, which is trained on public images, of course, the VERSE dataset, which we'll talk about later, the VERSE dataset, which will help us isolate the vertebral column from the images, from the patient's image. So VERSE dataset, in this case, is a public dataset, which has different DICOM imaging. There's two parts, of course, VERSE 2019, VERSE 2020. It introduced around 375 4 scans. And we, of course, align and project the images so that we have the sagittal view from the VERSE, and then we train our UNet model, and then we evaluate it, and then apply it on different images. This is the accuracy that we get. We get around 94% on the first isolation phase. Of course, the metrics we use here are binary cross entropy and Dice loss to evaluate the first or isolation phase of our model. And to show you what our model is doing here, let's say we have a sagittal view to the sagittal view of an image of a patient here. That's what the output will look like. We are trying first to isolate only the vertebral column of the patient. And this is using a trained UNet model on public images. This will be later used to patch it more into the specific vertebra, and then will be sent to whatever process or application we're gonna need patching for, even for reading or localization of the single vertebra. Then we're gonna talk about the second phase, which is the patching phase of our pipeline, which will take care of dissecting the specific vertebra of the image. And the key component here of the second phase is called SAM, which is by Facebook AI Research, is an open source segmentation model. Its work goes into segmenting specific areas of an image, but we will use it and we will tweak it to work on our isolated vertebral column images. Okay, so the first step here is to apply some classical morphology on the images, and then we apply some polynomial regression. Of course, we are not showing technical details here, but there's a huge complexity and mathematical complexity here because we are trying to apply some classical morphology and polynomial regression to plot or locate the vertebral column alignment to be able to segment each specific vertebra on its own. So the selected zone is then applied into specific filters to find the fine vertebras on the cells, of course, specific filters such as area, aspect ratio, and then the pipeline goes on into segmenting the specific vertebra on each on its own. So here we show how the first part of the second phase work, the patching phase. Here we have an image of a vertebral column. It's isolated by the first phase. We apply our methodology here. We try to find a region of interest. We deploy our polynomial regression in this case, and then apply our morphology to eliminate all impurities and find only the parts that we are looking for. So we are trying here to find each single vertebra on its own. That's here's the first phase. Of course, again, the technical details are not shown and how the specific extraction is going on here. And then we can show the final patching output. So each vertebra is being taken out on its own, which will be used, very important to be used later for in an AI model. So as a conclusion, Vcdissect is a pipeline that efficiently derives a region of interest of 2D sagittal view of medical images. We are here focusing on a vertebral column, and forward work will be deployed into an AI model applying 3D or different applications. Thank you.